First question, f of x, they give us equation. Plug -2 in, solved, got 30. C is the only one for number 2. Okay, y equals x plus 5. Okay, if you remember vertex form, okay, so we have y equals a times x minus h squared plus k, right? What is our a value in this one? 1, yeah, exactly, it's 1. Our h value? Yep, and our k value? Yeah, that's right, because there's nothing here, we just assume it's 0. So k deals with what? Say this is the original one, right? I'm going to quickly sketch it. 1, 1, 2, 4, 3, 9. Okay. Now, this is what's important here. They've drawn one, which was, it was a good guess. They've drawn one where it's over at -5. But I want you to look over how far it moves. It goes over 1, 2, 3, 4, up 4. So it goes over, when they've sketched this, and what's important here is the a value. It goes over 1, 2, 3, 4, and it only goes up 4. Okay? Normally when we go over 4, if our a value is 1, how many would we go up? If we were going over 4, what would we do to figure out how many to go up? Okay, our a value is 1, but how do we know where to go up 4 if it's just a normal function? We normally go over and square the number, right? So if I had to move over 4 from the vertex, what is 4 squared? Okay, and 16 times 1? Okay, but we still go up 16, so I would be way off this chart right now if this was a normal graph that was only shifted 5 to the left, okay? Now on the graph they showed us, if you look on that page, their second option, B, is it B? Oh, sorry, no, the first option, A. That was option B above in the book, okay? I've only gone over a couple here. They have the vertex at the number 5, and the only really distinct point they have is at 0 and 25, which also means that at about 10 and 25 they also cross. So roughly here. Okay. So it looks something like this. Now this one is a little harder to tell because we really don't have the intervals that we're used to seeing, right? These ones are going up by 5. So what I got to do is I got to use what they've given me. They've gone over 5. Okay. If A is 1, how many do we go up when we go over 5? Yeah, we got to take 5 squared, right? So 5 squared is 25. That makes perfect sense. If I've moved 5 to the right, I would go up 25 units. If I move 5 to the left, I'd go up 25 units. So wherever I go by, over by, I square that number. So that's why A is the answer. Even though it looks a little different from what we're used to seeing, because of the increments, that's the one we're going for. So we always got to try to pay attention to if it's been compressed or stretched. You're right, C and D didn't make sense at all. Okay, so we're looking for something that satisfies this, XCR. So first of all, does this linear line satisfy that? Does it go all along the x-axis forever? It won't? What do these arrows mean? It goes up and down, but it's also referring to left and right also. Okay. So will it go to the right forever? Yeah, and will it go up forever? Yeah, it's got the arrow. Will this go to the left forever? Okay, so XCR deals with our left and right, so x is the element of all real numbers. So will this go left and right forever? Okay, so that makes sense. Now we have YAR, so it's a continuous function. Y is the element of all real numbers, such that this means y is less than or equal to 10. We look at the number 10. Is this function stopping here? Is it going to continue to go? So does it satisfy this here? No, it doesn't satisfy this. So this straight line is not that. If anything, we would scratch this out, and the straight line would be the element of x is the element of all real numbers, and y is also. Okay. So the first one's no good. Let's get a quick draw of the second one here. Second one looks something like this. Okay. So it's something like this. Okay. Again, they have arrows at the end of it. Okay. This is roughly its shape. Let's talk about the first one, the domain. Does it satisfy x being the element of all real numbers? Will it go left and right forever? Why not?
Because it only goes. Actually,
Yeah, those arrows mean it's going to go that way forever. It'll go up forever, and it'll go right and left. So it does satisfy this. Okay, x does happen to be the element of all real numbers. What about our YER, or y being the element of all real numbers? It's definitely continuous, so it means there's a line connecting it. But it also says that y is less than and equal to 10. Do these values only exist below 10, or will they go past 10?
go past that.
They'll go past the number 10. So this one does not work either. Okay. Third graph they've given us, I'm going to freehand it. Looks something like this. Okay. Okay. So I want you to get the idea of it. I know we haven't really touched on it, but assume it'll never touch this line here. Okay, that's what it's pretty much trying to tell you. It'll never touch that point 0 there. So first off, does it satisfy x being the element of all real numbers? Does it pass every point in x? What about this middle line here? No. It doesn't pass that middle line. It doesn't exist there, so it doesn't even satisfy the first one. Okay? Because it doesn't exist when x is 0. So that doesn't work. And our final graph, which I don't think I can draw unless I do it freehand, so let's do this in blue, looks something like this. Oh, I didn't know. Okay. Our final one. Does this satisfy the element of all real numbers for x, the domain? Yeah, definitely satisfies that. It's continuous, so it satisfies our YER. And it says y is less than or equal to 10. Is 10 the highest point on this? Yeah, the vertex is at 10. So we're looking for answer D in that book there. Okay, the parabola that has a vertex at a y value of 10 and facing downwards. That's the one that'll satisfy this. So, in our fifth question here, talk about being which of these equations refers to this. Do you know what this represents? This represents a certain type of function when you graph it. It starts with a P. Yeah, this represents a parabola. So they want to know what would the function or the equation of a parabola be if this is what happened to the parabola. It got reflected on the x-axis and moved 7 units down. Which of these four, would represent the parabola? Okay. So let's talk about it. What form are they in? Do you know? Yeah, that's right. They're in their vertex form. So we have our A value, H, and we're going to squeeze K. Okay. So let's first go through figuring all these out. What are the A values? What's the A value in the first one? Yeah, in the second? In the third? Positive or negative? Negative 1. And good. What are the H values in the first one? Yeah, there is none, so we'll leave it at 0. And this one?
7.
And this one? Yeah, and? Good. And K values?
7.
Yep. Yep. Okay. So let's talk about these movements here. Reflected on the x-axis. What does that mean? First of all, which of these variables does it affect? Reflection on the x-axis. H deals with movements right and left. K deals with movements up and down. What does A deal with? So, what this is saying is reflected on the x-axis deals with A, and it tells us the difference between a parabola that's facing upwards and going downwards. This parabola here is our normal one. It faces up. So if it's been reflected on the x-axis, that means we now have a parabola that's facing downwards. So our A value is going to be what? Positive or negative? Positive makes it go up. Negative. So we now have an A value we know for sure. A is going to be negative for sure. So right off the bat, is this negative? Nope, so we drop that off. Is this negative? Nope, so we drop 2 of them off. Right off the bat, we know 2 of them are not the right answer. Okay, what about the last two? Are they both negative? Yeah, they're both negative. Okay, now let's talk about the other one. 7 units down. Is that dealing with H or K? K. If it's 7 units down, what is our K value going to be? Yeah, that's right, -7. Okay, so let's look at the only two options we have. Is K -7 in this one? Yeah, and is K -7 here? Okay, so they both fulfill it. What's the difference between these two? To the right one. That's right. Did it ask us to do that in here? So which of these two is our answer? The third one, that's right. They didn't ask us to move it, so we're looking for the third example in question number 5. Okay. Do you remember what causes something to be not a function? This one wants us to tell which of these is a function.
There's 2 points on one. 2 points on
X coordinate. Yeah, that's right. When there's 2 points on an X coordinate. Or vertical line test. Test is one of the tests we would use, right? So the very first one is A. If there are 2 points on the same X coordinate, okay? Now looking at a graph, it's kind of hard to tell, so what we do is we draw straight lines up and down, all the way across it. At any point, are one of these straight lines going to hit 2 points on the A? No, it will never do that. So does this pass the function test? Yes, this works. Okay. What about B? If I draw straight lines up and down, at any point, do I hit 2 lines or 2 points on this? No. So this also passes the function test. Okay. Now C is a little more confusing. These are actually coordinates. Okay. I want you to realize is what they point at. Oops, 1 pointing at 5. Think of it like the coordinate x is 1, y is 5. So we're going to plot these. Okay. So when x is 1, y is 5. That's 1 point. When x is 2, y is 23. That doesn't quite plan out here, so I'm just going to put it up there, okay? When x is 3, y is 12. So it's 3, y is 12. That's about there. When x is 3 again, y is 31, so it's another point above it on the same x-axis. And when x is 4, y is 23. Yeah, 23 again, so we'll say it's there. So we draw vertical lines here. These are the only points. Do I pass the first point? Fine.
Yeah.
The second point? Yeah. What about the third point? No, I crossed 2 points there. Okay. So what that means is C is not a function. And let's just double check with D. D gives us coordinates again. 8 and 9. So let's go 8 and 9. Here's a coordinate. 3 and 2. Here's a coordinate. 5 and 7. 5, 7. 1 and 0. And 4 and 6. So for all of these points, if I draw vertical lines, do I ever hit 2 points? No. So which is the only one that is not a function? C. C is the only one that is not a function. Okay? It does not pass that vertical line test. Or in other words, it has 2 values for the same x coordinate. Okay? When we're on x, we actually have 2 y values. Let's say we're going to factor this. We need to find the factors of the first term, 6x. So we have 1x and 6x, 2x and 3x. And factors of the last term, which is 10. So 1 and 10 and 2 and 5. We know that their products need to add up to our middle term, which is a negative 11x, right? So let's give this a try. Try the 6. 1 by 1 and 6 by 10, definitely not. It's going to give us 1 and 60, right? 6 by 1 and 1 and 10 is going to give us 6 and 10. Still won't work. 1 and 2, 6 and 5 is going to give us 2 and 30. No good. 6 and 2 and 1 and 5, that's going to give us 12 and 5. Does that work? No. So we know that this first set of factors doesn't work. Let's try our second set. 2 and 1, 3 and 10. 2 and 30, no good. 3 and 1, 2 and 10. 3 and 20, no good. 2 and 2, 3 and 5, that gives us 4 and 15. Any combination of that make 11? There we go. So, oops, how did we write that? There we go. 2 and 2 and 3 and 5. So that gave us 4x. 3 times 5 is 15x. You're right. If the 15 is negative, we add them together, we get 11x. So which number would we have to make negative here? Yeah, because we go multiply by 5. And how do we check? 2 times negative 5 is negative 10. So we know it multiplies together. So when we go to put it into our factored form, we take our first column. These are the first terms. So 2x and 3x. And then we go for our second column. Now, whatever we multiplied by have to go into an opposite bracket. So we multiplied 3x times negative 5. So 3x and negative 5 have to go in opposite brackets, which then leaves only one spot left for positive 2. So the missing factor in this one, since they'd already given us in the question, they already gave us 3x plus 2. That was already given. Our answer was the missing factor was 2x minus 5, which was B. Is that what you had?
Yeah.
Okay.
Yeah.
Okay. So we have a quadratic formula, polynomial here, and the first factor is k. Question asks us what makes this unfactorable. So which of these 4 values makes this unfactorable? Doesn't mean it's unsolvable. We may be able to find values of x. We need to go unfactorable, so what we're doing. So what we're going to do is we're going to trial and error. We'll do the very first one in red. When x is 1, sorry, k is 1, so we have 1 x squared plus 6x plus 8. We try factoring it. Second example, we try it when it's negative 2 x squared plus 6x plus 8. So we try those two out. Then we're going to try when it's the number 2. Extend this page a little. So that's when it would be 2x squared plus 6x plus 8. And finally, last example is when k would be 3. So that would be 3x squared plus 6x plus 8. Which of these 4 equations, maybe there's more than one, are unfactorable? We have to go through it and try to find out. Alright, so you've gone through it, and you think it's the last one. So let's test this one to see if it works. Factors of 3x are 1x and 3x. Factors of 8, 1 and 8, 2 and 4. Products need to add up to positive 6x. So, alright, so when we do our multiplication through, 1 by 1, 3 by 8, well that gives us 1 and 24, definitely no chance. 3 by 1 and 1 by 8, that gives us 3 and 8. Any sum of those equals 6? 3 by 4 and 1 by 2, that gives us 2 and 12. 10 is the lowest we could go there. And 3 by 2 and 1 by 4 gives us 6 and 4. No combination works. So you're right. The last one, D, is unfactorable. Now you said the other ones were factorable? You tried them out? Alright. Okay, so they're saying that this models the height of some rocket. And they want to know what the maximum height of the rocket is. So, you're right. We can definitely put this into vertex form, which is our completing the square. Now, technically, at this point, you hadn't learned that yet, but that's fine. We can definitely do that because now we have more knowledge. We know a fast way to solve it. There. What I'm going to do here is I'm going to show you 2 versions of this. We're going to complete the square on the right, or put into vertex form, the square. And on the left, I'm going to factor. I'm going to factor, then solve x, then axis of symmetry, and then the vertex. 4 steps to this one. Okay, we're completing the square. It will take us 1 through it. We'll go through it at the same time. Okay, so on the left, we have negative 5. Well, sorry, let's put h of t. So the height, in reference to the time the rocket spends in the air, negative 5t squared plus 22t. On this one here, we have h at t is equal to negative 5t squared plus 22t. Now, talk about the one on the left first. Very first style of factoring. You know what we look for? Greatest common factor is what we always look for. So GCF. Greatest common factor here. Anything I can take out? I can take out a negative, and I can take out t. Okay? So what we're going to do here is we're going to take out negative t. That means I can divide both of these terms by negative t, and we're left with something inside. So when I divide the first term by negative t, I get positive 5t. When I divide this by negative t, I get minus 22. So there's my factor form. Right? Now in this one, the very first thing we need to do in completing the square is we divide the first two terms by the coefficient in front of x. Now in this one, we divide by negative 5. Okay? Kind of the same idea. A little different though, because what happens here is the negative 5 becomes the factor we've taken out. And we end up with t squared, and then you could say minus 22t divided by 5. A little bit tougher of a number to work with when we're completing the square. Okay? Now on the left side again, I need to solve for t. So in other words, I need to set h at t equal to 0. We're trying to find the x-intercepts. So I'm going to set h at t equal to 0. So I get 0 is equal to negative t, 5t minus 22. And then from there, what I want to do is split these into two. There's actually two different answers I'm going to get. Here's our first number, and our second number is actually just negative t. So when we split those up, I get 0 equals negative t, and I get 0 is equal to 5t minus 22. Okay? We'll solve those in a second. On the right side, what we want to do is our little side calculation. Remember, we take our new b value, b divided by 2 squared. I'm going to tell you a trick. When you have a fraction, just bring the 2 to the bottom of the fraction and multiply it by the denominator. Okay? So our new b value is actually going to be negative 22. Let's give ourselves a little bit. We get negative 22 divided by, and it's going to be 5 times 2, so 10. Then we're going to square it. So I got to figure out, I know 10 squared is going to be 100, but I got to figure out 22 squared. 22 squared, 484. So my new fraction, the number I'm going to add and subtract inside, is 484. Keep that up. Okay. So that means I'm going to add and subtract that. So I'm going to put it in here. We get negative 5, so we will squish t squared minus 22t divided by 5. And we're going to add and subtract this fraction. Now you can make it a decimal if you like. The reason I keep it in fraction is because you're going to figure out it's going to be really easy to square root after if we keep it in fraction form. Okay? So I'm going to add 484 over 100, and I'm going to subtract 484 over 100. Okay, so that's our completing the square. Let's jump back to the left now. On the left, we got to solve our t values. Okay, so in this one, t is just equal to, when I divide by negative, it's still 0. On this one, I bring 22 over, so I get 22 is equal to 5t. So I get t is equal to 22 divided by 5, which I want a decimal for. 22 divide 5, 4.4. So I've discovered my two x-intercepts, or 4.4. My two x-intercepts are 0 and 4.4. That doesn't quite give us our vertex, though. We're trying to find the highest point of this rocket, right? So we're going to keep going. On the right side, let's continue with completing the square. I want to take out the negative version of the number I did, and I got to multiply it by negative 5. So again, going to look a little confusing when I rewrite this here, but we're going to get negative 5 t squared minus 22t divided by 5 plus 484 divided by 100. Now, when I multiply negative 484 over 100 by negative 5, first of all, it will become positive or negative? Positive. And if I'm multiplying this as a fraction, how do I make negative 5 a fraction? Yeah, good. So 100 times 1 is going to be, so we know our denominator is still going to be 100. Our numerator, 484 times 5, well, we'll put in the calculator. 484 times 5. 2,420. 2,420. Okay? So we have that there, our vertex. Okay? Now we still have to keep going. In this one, we found our two x-intercepts. Do you remember what the axis of symmetry formula is? Yeah. So we add the two x-intercepts and divide by 2. So our axis of symmetry, our two x-intercepts are 0 and 4.4 divided by 2. Well, it's going to be 4.4 divided by 2, which is going to give us 2.2. Okay. So our axis of symmetry, or the x value of our vertex, right? We know our vertex now. The x value is going to be 2.2. I'm just going to have to find the y value, right? Now, on our completing the square, we technically have one more step here. We need to find the square root of the first and last term. Looks like it could be confusing, right? Let's bring this down. -5. What is the square root of t squared?
T.
Just t. Bring the t down. Now, I'm going to show you a trick. Square root of 484 divided by 100. That can be tough. Why don't we split it up? What's the square root of 484? I want you to look back at your calculations. Yeah, it's going to be 22. Remember, we had to square that number to get 484. So the square root of that is going to be 22 on top. And what is our square root of 100 going to be? 10. Remember, that's the exact number we squared earlier. 22 and 10. Okay? And then end bracket. And finally, what sign do we bring down? Yeah, we bring that negative sign down. So it's a negative. We make sure to square this on the outside. And we still have our 2420 over 100. Okay. So what that is this is in vertex form, right? What is our vertex in this one here? Is our x or y value? That's right, that's our y value, 2420 over 100. And our x value is positive 22 over 10. Now let's actually make those into decimals. Okay. While we do that, on the other side, I have my 2.2. I'm just going to quickly plug it into the original equation. Okay, so the original equation, while you're doing that, is negative 5t squared minus 22t. We're going to replace both the t values with 22. So negative 5 times, sorry, not 22, 2.2 squared minus 22 times 2.2. That's going to give us 4.84. 4.84, I think. And then this one is going to give us 48.4, I think. 0.4. Negative 5. 5 negative times 4.84. Negative 24.2. Negative 24.2. I think we've messed something up here. Oh, sorry, it was plus 22, the original equation. So this is a plus. There we go. Plus 48.4. So the y value of our vertex, according to this, 24.2 plus 48.4 is 24.2. Okay? And when you divided those fractions, is that what you got for your vertex? 24.2. And our vertex here was 2.2, or 22 divided by 10, which is 2.2. 2,420 divided by that is 24.2. Either of them got you the right answer. Which you felt more comfortable with is a different question. Okay? So we got our vertex on the left, and we got it on the right. There's quite a bit we could have done in that question. Okay? Does that one make sense? Okay. Next question asks us for area of a rug, I think it is, a rectangular enclosed area, something like that. Now, because it's multiple choice, they've given us options. They want to know which of these options, 5, 13, 10, or 7, will give us a area of 130. Okay? So what we could do is trial and error, plug each of these in. Or what I could do, and we're going to do both, okay, is I can plug this area in for this number here. Okay? And I'll walk you through that process quickly. Okay? Do this quick. So I'm going to do it on the right, actually. I'm I'm going to walk you through the factoring one, and then we'll just solve the answer and check on the right, okay? So I'm actually going to move this over so we have, we'll just solve the answer. So we're going to factor here. So what that means is I now replace area, the AW, with 130 is equal to negative 2W squared plus 36W. Okay. Now in order to solve for W, I need to move 130 to the other side of the equation. So it becomes 0 here. Negative 2W squared plus 36W minus 130. Now I work on factoring. I can actually take a greatest common factor out of negative 2, which will give me W, minus 18W plus, this becomes 65. Okay? So my common factor was 2. I then work on factoring that. W and W. 65 gives us 1 and 65. 3? No. 4? No. 5 goes in. 5 goes in 13 times? Yeah, that's what we're going to be looking for. There may be another factor, but I'm going to tell you that's the one. Okay. Because when we multiply 1 by 5 and 1 by 3, 5 and 13 add up to 18 if they're both negative, right? If these are both negative, negative 5 times negative 13, does that give you positive 65? Yeah, negative times negative is positive. So that works out perfect. We have 0 is equal to negative 2, and in our brackets, now they're the same term, so it doesn't matter which of these they go into. We have negative 5 and negative 13. Okay, so I need to isolate for my two brackets. So I divide each side by negative 2. What's 0 divided by negative 2? 0. 0 equals W minus 5, W minus 13. Split the 2. Okay. 0 equals W minus 5. 0 equals W minus 13. Our answers are W equals 5 or W equals 13. Both are options. What have they given us up here? They've given us two options, 5 and 13. So what you would do is plug them both in just to make sure they work. But in this case, according to this, a width of 5 or a width of 13 will give us that answer. Okay? Okay?